Hello students, welcome back to the 8th video of this playlist. So in this video, we will be solving question number 8 from October 2024 Pure Mathematics 2 paper. So October 2024 paper is the latest paper that is available right now. So let's see what's the question number 8 from the most recent P2 paper, that is October 2024 paper is about. Okay, so you can see question number 8 on the screen. So basically the concepts behind question number 8, it's basically from integration. To be more specific, we need to find out the area under the curve using integration. And so this concept has been discussed in chapter number 8, the last chapter of your P2 textbook. And besides that, at the beginning we need to have some idea about algebraic methods, like how to solve algebraic equations, and yeah, points of intersection. So let's get started with the 8th question from October 2024 P2 paper. So at first, figure 1, two curves has been sketched there, C1, curve C1 and curve C2. So figure 1 shows a sketch of part of the curve C1 with equation. The equation of curve C1 is y equals to x squared plus 3, and it is on the positive x-axis, that's why x greater than 0. And part of the curve C2 with equation y equals to 13 minus 9 over x squared. It is also on the positive x-axis, so x greater than 0. Okay, so the curve C1 and C2 intersect at the points P and Q as shown in figure 1. So we can see in the figure 1 that the curve C1 and C2, they are intersecting each other at point P and point what? Q. Fine. So part A is asking here to use algebra to find the x coordinate of point P and the x coordinate of point Q. That means we need to find out the point, the x coordinate of the points of intersection. That's it. Okay, so at the point of intersection, what we know, at the points of intersection, we know that at the points of intersection, since point P and Q are common points that lies on both the curves, so their y values will be equal, isn't it? The y value for the equation of curve C1 and the y value for the equation of curve C2 will be what? Equal. So we can write x squared plus 3 equals to what? 13 minus what? 9 over x squared. Fine. Okay, so take all the terms on the left side. Okay, so you'll get x squared plus what? 9 over x squared, and then 3 minus 13, that would give you negative what? 10 equals to 0. Okay, now multiply both sides by x squared, so you will get x to the power 4 minus 10 x squared plus 9 equals to what? 0. Now we can do middle term factorization here, isn't it? How can we do that? Okay, yeah, so x to the power 4 negative what? 9x squared negative x squared plus 9 equals to 0. Fine. So what we can do here, we can take x squared common from the first two terms, right? So if you take x squared common, then what you will get? You will get x squared minus 9, x squared minus 9, and then from the last two terms, what we can take common? Only 1. Minus 1. We can take what? Minus 1 common. Okay. So if you take minus 1 common, then minus x squared plus 9. Is it minus x squared plus 9? Yeah. Minus x squared plus 9. Fine. Okay. So this equates to what? 0. So either x squared equals to 1 or x squared equals to what? 9. So you will get what? X equals to plus minus 1 or x equals to what? Plus minus 3. Okay, but point P and Q both are on the positive x-axis, so at P, let's see which one is point P. Point P is the first one. So at point P, it will be smaller x coordinate. X equals to what? 1, and at Q, what? X equals to 3. Done. That's it. So we got the x coordinate of point P and point Q. One is at P it is 1, and at Q it is what? 3. That's what part A of question number 8 has asked for. Okay, next is part B. So in part B, it's saying the finite region R shown shaded in figure 1 is bounded by curve C1 and C2. So you can see the region R, it is bounded by the two curves, isn't it? Okay, so now part B is asking to use algebraic integration to find the exact area of R. Okay, so we need to find out the exact area of region R. Fine. So we know the x coordinate of point P and also the point Q. Now we can see in the figure 1 that the region R, it is between the point P and point Q. Okay, so how can we find out this area? Let's have a look. So if I consider, look, this region, okay, this is the x coordinate of point Q. This is x equals to 3, and this is x equals to 1. Okay, so we know the equations of the two curves C1 and C2. Fine. So what we will do is that we will find the area under the curve C2 and the x-axis, this region. This is basically that region. Okay, that whole region. And from that whole region, what we will do next? Basically, we will what? We will subtract the area under the curve C1. Okay, curve C1 is which one? That one, the one it goes up. Okay, so we will subtract, this area will be that part. Okay, so if you subtract this part, we will get the area of region what? R1. Okay, it got erased. Okay, fine. So let's see what we can do now. We have to do integration. Okay, so area of region R, we know the equation of curve C1, it's what? At first, the equation of curve C2. Equation of curve C2 is 13 minus 9 over x squared. Okay, so part B, what? Area of region, what? Region R, it's what? We need to integrate from upper limit is what? 3, lower limit is 1, and equation of curve C2, it's basically, isn't it C2? Yes, the larger area is C2, under C2, which has equation 13 minus 9 over x squared. So 13 minus 9 over x squared, so make the power visible. So x inverse 2 dx. From that, subtract what? The area under the curve what? C1. So this is the smaller area which is under C1. So equation of curve C1 is x squared plus what? 3. X squared plus 3 dx. Now just simple integration. It's integrating in definite integral. Okay, so we'll get 13x, and then what? We basically add 1 with the power, right? And then we add 1 with the power of the variable, and then we use the new power of the variable to divide the what? Coefficient. So here the power is what? X inverse 2. So it will become x inverse 1. So new power is negative 1. So use this negative 1 to divide what? Negative 9. So you will get plus 9. Okay, this is definite integral. Upper limit is 3, lower limit is 1, minus. So same way as integration, you will get what? 1 over 3x cubed plus what? 3x. Upper limit is 3, lower limit is what? 1. Okay, now find out the values. 13 times 3 is what? 39. Okay, plus 9 over 3 is what? 3. Then minus 13 minus what? 9. And then here you got minus what? 3 cube is 27. 27 over 3 is what? 9. plus 9 minus 1/3 minus 3. Okay, now just calculate 39 plus 3, this is 42. So 3 minus 13, this is what? Negative 10. So 13 minus 10 is 29. 29 minus 9 is what? 20. Okay, minus you got 9 plus 9, 18. 18 minus 3 is what? 15. So minus what? 15 plus 1/3. So what would be the area? That would be what? 5 plus 1/3. So this is basically 16 over 3. Okay, so this is 16, because if you take LCM you'll get 15 plus 1, which is 16 over 3. They ask for the area, right? Area, exact area of region R. So since they ask for the area, so that is 16 over 3 unit squared. So we got the area of the region R, that is 16 over 3 unit squared, and that's what exactly part B of question number 8 has asked for.